In this video, I will go over your Pre-Calculus Unit 5 test review. For the test, it is entirely non-calculator, but you can use your formula sheet that has all your trig identities on it. So you want to make sure to have that. And then you can also have a completed unit circle. Okay, so this first problem, given that cosine of x is 3/4 and x is in between 3 pi over 2 and 2 pi, which means it's going to be in the fourth quadrant. Okay, so in the fourth quadrant here, we're trying to find sine. What that piece of information is going to be used to find is whether it's positive or negative. So in this case, sine is going to be negative. Okay, so I'll put a negative there. The way I approach these is to make a triangle. So this is going to be x. If cosine is 3/4, the adjacent side is going to be 3. The hypotenuse is going to be 4. To find sine, we need the opposite side over the hypotenuse. So I'm going to say 3 squared plus x squared equals 4 squared. So 9 plus x squared equals 16. So if we subtract 9 from 16, we get 7. So x, which really is kind of a bad variable, but whatever, is the square root of 7. So my sine is going to be the square root of 7 over 4. In the next one, I'm going to do the same thing. This is telling me that we are in the second quadrant, which means our secant is going to be negative. Okay, because our x values are negative in these two quadrants. And so if cosine's negative, secant is negative. We'll make our triangle. Opposite is 2, hypotenuse is 7. For secant, we need the adjacent side. So 2 squared plus the adjacent side squared equals 7 squared. So x is going to equal the square root of 45, which you can simplify that. I'm just going to go ahead and write my answer as if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. Okay, you could simplify this radical, you can rationalize, or you can leave it just like that. Okay, for these next two, we want to express in terms of sine. So we know sine squared theta plus cosine squared theta equals 1. So I'm going to solve this for cosine. Cosine squared will be 1 minus sine squared. So then to get rid of the squared, we're going to take the square root. When we do, though, it is both plus and minus 1 minus sine squared. For tangent, tangent is sine over cosine. So we have a sine here, but for the cosine, I'll go ahead and replace it with what we found here. Okay, for these next problems, we are simplifying. So one strategy in doing that is to turn everything in terms of sine and cosine. So cosecant is 1 over sine, and we've got cosine, plus cosine over sine. All of that over 1 over cosine times cosine over sine. Okay, so moving across here, we're going to have cosine over sine plus cosine over sine. In the denominator, the cosine here and here cancel. So I have 1 over sine. Okay, if I combine these, cosine over sine plus cosine over sine is going to be 2 cosine over sine. And then I'm going to multiply that by the reciprocal here. So the sines cancel. And we get 2 cosine x. Okay, so we're going to write as a single trig function. So write everything in terms of sine and cosine. Okay, so I have 1 over cosine x sine of x minus cosine of x over sine of x. To get a common denominator, I need to multiply this one times cosine over cosine. So in the numerator, I'm going to have 1 minus cosine squared x, when I multiply those, over sine of x cosine of x. Well, we know cosine, 1 minus cosine squared is sine squared. Okay, one of the sines will cancel, so I'll cross off the 2 and cross off the sine. So what we're left with is sine over cosine, which is tangent. All right, so in our next problem, so these are all these verifying problems. They're going to vary in difficulty. Strategies are pick the more complicated side. So I'm going to pick this one. Turn everything in terms of sine and cosine. And this one's pretty darn simple. I have a common denominator, so this is 1 minus sine over cosine. All right, this next one, I'm going to go ahead and write this as a sine squared. Cosecant is 1 over sine. The sine on the top and the bottom cancel, so we're left with sine over cosine, which of course is tangent. Okay, this one. I have a common factor that I'm going to pull out. I'm going to factor out a sine squared x. That leaves me with cosine squared x plus sine squared x. Okay, well this is just 1. So quite quickly we just get sine squared. All right, this one, 1 over cosine minus cosine over 1 plus sine. Next up, I'm going to get a common denominator. So I'm going to multiply this one times 1 plus sine over 1 plus sine. Here I'm going to multiply by cosine over cosine. So this times this is 1 plus sine theta, and then we're minusing cosine squared theta, and then this is all over 1 plus sine of theta times cosine of theta. Well, different things. If you have a 1 minus cosine squared, if I rearrange this, that's going to be replaced with a sine squared. And I didn't multiply the denominator because if I do, we end up with like a sine cosine and nothing really helps us there. So I'm going to leave it in the factored form. And speaking of factoring, that's what I'm going to do in the numerator. I'm going to factor out a sine, which leaves me with 1, or a sine plus 1. Okay, the 1 plus sines cancel, so we're left with sine over cosine, which is tangent. So getting common denominators. Replacing the identities, so 1 minus cosine squared became sine squared, and then factoring. Factoring is a big deal here. So for number 11 here, I'm going to choose to work with this side. I'm going to turn cotangent into cosine squared over sine squared. Cosecant is going to be 1 over sine of x plus 1, but I'm going to go ahead and write that as a sine of x over sine of x just to save me some space here. Okay, then I can combine those. And actually I'm going to do two things. I'm going to do this, I'm going to add these, and then I'm going to multiply by the reciprocal of that result. So that's going to be sine of x over 1 plus sine of x, because if I combine it, we have 1 plus sine over sine. Okay, so a sine cancels. So we're left with cosine squared, which I'm going to replace with, because there's no cosines here, replace that with a 1 minus sine squared. And that's going to be over a sine of x, 1 plus sine of x. Okay, I can factor this. This is the difference of two perfect squares. So that's going to be 1 plus sine of x times 1 minus sine of x. Okay, the 1 plus sine of x will cancel. So that leaves me with 1 minus sine of x over sine of x. Looking at what I'm trying to get here, I'm looking for a cosecant minus 1. So if I split this up into 1 over sine of x minus sine of x over sine of x, undoing basically the common denominator. 1 over sine of x is cosecant of x. Sine over sine is in fact 1. Okay, here, you may be tempted to distribute, but this is not the distribution because it is not multiplication. So here, we're going to use the sum identity for cosine. So my a in this case is going to be pi, my b in this case is going to be x. On this side of the equation, whatever is here is the opposite. So since we have a plus, it's going to be a minus here. So when I expand this, we get cosine pi cosine x minus sine pi sine x. Then these two, we use our unit circle. So on the unit circle, the coordinates at pi are -1, 0. So my cosine value is -1, my sine value is 0. So this is going to be a -1 cosine of x minus 0 sine of x. So that goes away, and we're just left with negative cosine x. So we're just simply using the identity. This one here, I'll make this 1 over cosine of x plus sine of x over cosine of x. So I get 1 plus sine of x over cosine of x. Well, we get to kind of the stopping point. So in order to make this turn into this, I'm going to make a more complicated version of it by multiplying by my fancy one. I know I want a 1 minus sine, so I'm going to multiply this by 1 minus sine over 1 minus sine. Foil the numerator, so we're going to have 1 times 1 is 1, minus sine, and then a plus sign, so the middles will go away, and we just have sine squared over cosine of x, 1 minus sine of x. Okay, well, I'm trying to arrive at this. 1 minus sine squared is cosine squared. Okay, and then the cosines do cancel. So 1 cosine there and there. So what I'm left with is exactly what I'm looking for, cosine of x over 1 minus sine of x. Okay, on this one, you can either factor the trinomial or expand this side. So that's what I'm going to do here. This is going to become sine squared x times sine squared x. Then I can turn each of those into 1 minus cosine squareds. And then FOIL. So we'll have 1 minus cosine squared x minus cosine squared x plus cosine to the 4th, which if I combine my like terms is 1 minus 2 cosine squared x plus cosine to the 4th. Alternatively, you can factor this. This factors 2 cosine squared x minus 1 and cosine squared x minus 1, which is a negative sine squared, which is a positive sine to the 4th. So either of those is acceptable. This one is probably a little bit easier because it's just multiplication versus factoring, but both of them are acceptable. Okay, on this next page, we have a whole bunch of different things we're trying to find. X and Y are some angles. We do not know what those angles are, but we don't need to know them because we know that the sine of this angle is 8/17 and the cosine is 3/5. For all of these identities, we need sine of each of x and y and cosine of x and y. So I'm going to go ahead, just like the first problems, and make a triangle. We're going to have one triangle for angle x, and we'll have one triangle for mystery angle y. Sine of x is 8/17. So if I want to find this side, we'll just name it A for adjacent. A squared plus 8 squared equals 17 squared. So plus 64 equals 289. So A squared is equal to 225, which means A is 15. Okay, that helps me because that means that my cosine of x is 15/17. For angle y, whatever angle y is, the adjacent side is 3, the hypotenuse is 5, so I don't even need the Pythagorean theorem to know that's going to be 4. So the sine of y is going to be 4/5. Okay, so the next thing I'm going to do is expand using the identity. So the identity, some identity for sine, is sine of x cosine y plus sine of y cosine of x. Okay, some people get confused and think that x is 8/17, but it's not. It's the sine of x is 8/17. So this gets replaced entirely with 8/17. So this is 8/17. Cosine of y is 3/5. Sine of mystery angle y is 4/5. And cosine of x we found to be 15/17. So this will be 24/85. So if I multiply 5 times 10 is 50 plus 5 times 7 is 35, 85. Plus 4 times 15 is 60. Oh, apologies. This is minus, so this should be minus here. Okay, so this is minus. So 24 minus 60 gives me a negative 36/85. Okay, for cosine of x minus y, that's going to be cosine x cosine y. If this is a minus, this will be a plus. Sine is the same, cosine is opposite. Sine x sine y. And then again, just make those replacements. Cosine of x is 15/17. Cosine of y is 3/5. Plus sine of x is 8/17. sine of y is 4/5. So we get 3 times 15 is 45 over 85, and 32 over 85, which is 77 over 85. For tangent of x plus y, we know the sine and cosine of those. So x and y are just angles. X minus y is just another angle. We don't know what that angle is, but we know its sine and cosine values. So this is going to be sine of x minus y over cosine of x minus y, which is just going to be negative 36 over 85 over 77 over 85. We have the same denominator here, so this is negative 36 over 77. There is a tangent identity, but you do not need it. We have x and y, and it's going to be the same thing on your test. So sine, cosine, tangent. My sine of x minus y ended up being negative. My cosine was positive. So on the unit circle, or on our anything, if my sine is negative, but my cosine is positive, we are in the fourth quadrant because x's are positive, but the sine or y values are negative. Secant of x minus y is just going to be the reciprocal of cosine. So if cosine is 77 over 85, secant is 85 over 77. Okay, the half angle identity. So the half angle identity for sine says plus or minus the square root of 1 minus cosine of x over 2. Okay, well, if x is in the first quadrant and I cut it in half, it's still going to be in the first quadrant. So it will be positive. So 1 minus the cosine of x is 15/17. And then the rest of this is just simplifying. So this will be 17 over 17 minus 15 over 17 is 2 over 17. Okay, and then if I divide 2/17 by 2, we have 1/17. So you can leave it like that. You can write it as 1 over root 17, or if you wanted to rationalize it, we'd get root 17 over 17. Then we have the double angle identities. The double angle identity for cosine is cosine squared x minus sine squared x. And then replace. Cosine of x is still 15/17 squared minus sine is 8/17. So 225 over 289 minus 64 over 289 is 161 over 289. The identity for sine is 2 sine, in this case y, cosine y. So we have 2, the sine of y was 4/5. The cosine of y is 3/5. So this is going to be 2 times 4 is 8 times 3 is 24 over 5 times 5 is 25. So in all of these, you find the other two trig functions that you're not given, and then just simple replacements with the numerical values. All right, we're going to find the exact value of the sine of 105. So the trick for this, using the sum and difference, is to rewrite 105 as the sum or difference of two unit circle values. So I'm going to choose 60 and 45. Then expand using the identity. So sine of 60 cosine 45 plus sine 45 cosine 60. And then use your unit circle to evaluate those values. So the y value at 60 is root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 45 is root 2 over 2. Cosine of 60 is 1/2. So root 3 times root 2 is root 6 over 4 plus root 2 over 4. So our exact value is root 6 minus root 2 over 4. Pi over 12. So when we're in radians, I'm going to rewrite this as cosine of, I'll do 4 pi over 12 minus 3 pi over 12. I pick those values because if I simplify them, this is really pi over 3, this is really pi over 4, which are unit circle values. Then we'll expand using the identity. So cosine pi over 3, cosine pi over 4. If this is minus, this is plus. Sine pi over 3, sine pi over 4. This is 1/2 times root 2 over 2 plus root 3 over 2 times root 2 over 2, which will give us root 2 plus root 6 over 4. Okay, for the half angle identities, we want to write it in terms of an angle over 2. So I'm going to rewrite 15 as 30 over 2, and then I can use the half angle identity for tangent. So half angle identity for tangent is this. Okay, 15 degrees is in the first quadrant, so this is going to be positive, and then it's going to be 1 minus cosine 30 over 1 plus cosine 30. 30 is, cosine of 30 is root 3 over 2. So we're going to end up with here is, I'll turn this into a 2 over 2. So 2 minus root 3 over 2 over 2 plus root 3 over 2. The 2's cancel. So we have 2 minus root 3 over 2 plus root 3. And you could simplify more, but I am fine just leaving it like that. For pi over 12, that's going to be the same thing as cosine. Just like here, I doubled it and divided by 2. So I'm going to double this, which would make this 10 pi over 12 over 2. If I were to simplify that, we get this. But that ends up being the same thing as the cosine of 5 pi over 6 over 2. Okay, then I'll use the half angle identity. 5 pi over 12 is less than 6 pi over 12, so it's in the first quadrant, so it's positive. Okay, so just replace the identity. Cosine of 5 pi over 6 is root 3 over 2. And then lost my train of thought. 5 pi over 6, the cosine value there is negative. So this should be a negative over 2. So this will be 2 minus root 3 over 2 over 2. So 2 minus root 3 over 4, which will be 2 minus root 3 over 2. All right. And the last thing you're going to have on your test is solving trig equations using various techniques. This first one, I'm going to factor. Okay, and then we can set each of those equations equal to 0. So tangent x equals 0, secant x minus 2 equals 0. That only works if this is 0. So we're looking for all values where tangent is 0. Tangent is 0 at 0, and then I'll add plus 360k, and it's 0 at 180, plus 360k. So I'll find the unit circle values and then just add 360k. Secant of x equals 2, which means cosine of x equals 1/2 on our unit circle. So I'm looking for where my x values are 1/2, which are going to be at 60 degrees, add 360k, and at 300, where the x values are 1/2. Okay, so principal values are the highlighted unit circles. We have a cosine 2x, so I'm going to replace that with cosine squared x minus sine squared x. Or you can use one of the variations, and probably a better choice for that really would have been, so we have cosine squared minus sine squared. We have the two versions where we've replaced this with 1 minus sine squared and this with 1 minus cosine squared. So this might have been a better choice, but I can still arrive at that if I don't. So I'm going to replace this with 1 minus sine squared to get it all to be the same trig function. So this is 1 minus 2 sine squared x, which is the one that's on our identity sheet. Well, I'm going to have a trinomial, so I'm going to move everything to one side. Since this is minus, I'm going to move it over here. So we have 2 sine squared x plus sine of x minus 1. And then we're going to factor. This is pretty simple factoring because the numbers are real small. If this is a 2 sine squared, we have a 2 sine of x and a sine of x. And then if this is minus 1, this is 1 and 1. My two options are plus minus or minus plus. If this middle term is plus, this will be plus because that will give me a positive 2 and a minus 1. So when I set these equal to 0, either sine of x equals 1/2 or sine of x equals negative 1. For principal values, there's just one value that works. So between negative pi over 2 and pi over 2, sine is 1/2 at pi over 6, and sine is negative 1 at negative pi over 2. This one, we don't have any squares, it's just going to be simple solving. So I'm going to go ahead and add the 3 cosine over here, so we have 6 cosine of x, and then subtract 5, so we have negative 3. So if I divide by 6, we have negative 1/2 equals cosine of x. In this case, we're solving between 0 and 180, so our x value is negative 1/2 at 120 degrees. Degrees because this is given in degrees. Okay, this one looks very similar to the number 27 on this page. So this will be 2 cosine and cosine. This is 1 and 1. For this to be positive, this is positive, this is minus, because that would give me a plus 2 minus 1. So either cosine of x equals positive 1/2 or cosine of x equals -1. This is all real values in radians. So find the unit circle values. So our x is 1/2 at pi over 3 and 5 pi over 3. And then we're going to add 2 pi k. Our x is -1 at pi, and we will add 2 pi k. All right, for this one, 4 sine squared x equals 1. When we have a squared, sometimes we're going to factor, but if I only have one trig function, I can just isolate that trig function. So sine squared x is going to equal 1/4. Then I'm going to take the square root. So sine of x is going to equal plus or minus. The square root of 1/4 is going to be 1/2. Just don't forget the plus and minus. Because this, if it's 1/2 and we square it, we get 1/4. If we have a -1/2, we square it, we get 1/4. So between 0 and 360, we're looking for positive 1/2 or negative 1/2 for our y values. So that will be at 30, 150, 210, and 330. For this one, you may be tempted to divide both sides by tangent, but that will potentially remove answers. So I'm going to go ahead and subtract the tangent. Then I can factor the tangent. Okay, so either tangent of x equals 0 or 2 cosine squared x minus 1 equals 0. So I'll solve this one real quick. Between 0 and 2 pi, tangent is 0 at 0 and at pi. This one is going to be pretty similar to the last one we did. 2 cosine squared x equals 1, so cosine squared x equals 1/2. So cosine of x equals plus or minus the square root of 1/2, which is 1/√2, which when rationalized it is our more familiar root 2/2. So we're looking for all 4 locations where our x value is either positive root 2/2 or negative root 2/2, which is at all of the pi over 4s. So pi over 4, 3 pi over 4, 7 pi over 4, and 11 pi over 4. Here we will factor, so I'll factor out a sine. That leaves me with a sine of x plus 1. So either sine of x equals 0 or sine of x equals -1. Principal values, this will be 0. This will be negative, in degrees, -90. All right, and our last problem here, we're going to use the sum and difference identities for sine, and we have 2 of them. So this is going to get very, very big before it gets small. So this one, we're going to have sine pi over 6 cosine x plus, so this is this, I'm going to do it in 2 colors, sine of x cosine pi over 6. Then we're going to add that to this one expanded, which will be sine pi over 6 cosine x minus sine of x cosine pi over 6. Then all of this equals 1/2. All right, so first the sine x cosine pi and this one are going to cancel. Cosine, or sine of pi over 6, our y value of pi over 6 is 1/2 cosine of x, and then this is also 1/2 cosine of x. 1/2 plus 1/2 is 1, so cosine of x equals 1/2. Between 0 and 2 pi, our x values are 1/2 at pi over 3, and at 5 pi over 3. So those are the things that you need to know how to do for your Unit 5 pre-calculus test.